looks like a database, acts like a database, performs like a database, then yes, you can use it to replace the data model. What we need is a good query capability, and we need very low latency. Once we get to that point, then yes, we can successfully get rid of data marks using Hadoop or using other big data technologies. When I talk about latency, if we take, say, OLAP, online slicing, dicing, dragging, dropping, I'll show you a demo of that later. The idea is to maintain a thought process. The user is looking at the data, they're thinking of things, they're dragging dimensions around, and the target is to get every query back within 5 seconds. That's from the end user's experience. So that includes the UI presentation, it includes network latency, it includes reading the data to the server, and for any one display, you may be issuing 5 to 20 queries. So the latency we're looking for is sub 100 milliseconds. That's the latency we need in order to be able to use something like Hadoop for business intelligence. If we look at the advantages of Hadoop, obviously the distributed processing, the distributed file system, the commodity hardware, these are the things that are attractive to people when they're looking at using Hadoop for the API system. If you look at the cost of the NetEases and Teradatas, those systems are very, very expensive, and so Hadoop looks very attractive from this perspective. And a lot of these companies people I talk to, the only viable solution. They physically cannot afford any more Oracle or any more T0 or any more Teradata because no one has a $10 million question. And that's what it would take to use one of those technologies to store this data return. That one I covered. So, and this is a quote from an ETL developer that I talked with. This is someone that's used to using Informatica and then had to go write MapReduce jobs to try and do what you would do in Informatica. So you've got users who are used to an interface like this, where you've got a palette of things you can do with the data, you drag them in and you stream them all together, you set the properties, and then you hit run, and my data comes out the other end. If you take those people and you give them this, it's a very awkward silence. And another issue with MapReduce is very, very good at mapping and reducing. Unfortunately, if you look at data transformation, you've got lots of other things that you need to do with data. You need to dedupe it, you need to merge it, you need to aggregate it, you need to transform it many, many different ways. Mapping and reducing are 2 of those ways, but unfortunately it's only about 10% of the things that you need to do. So MapReduce is a subset of what the data transformation needs to be. So it ends up being very awkward. Trying to do everything with MapReduce is like trying to do everything with recursion. Sure, you can do it, but if you've got a strictly iterative problem, using recursion makes no sense. You end up with something that's actually slower, less performant, has memory restrictions, and it's harder to document and maintain. But it's very, very good at mapping and reducing. It's also, I have a problem with the name. You add another function to that thing, and what happens to the name? Don't take the names of functions and the names of so part of we go back and look at the history very quickly. I won't spend a long time with this audience on history. Just look at what Google was doing when they created MapReduce. We all know what they were doing. We know what their input was, what their output was, what their user community was. So they came up with MapReduce. If you look at Yahoo's initial use case, it's the exact same use case, the exact same input and the exact same output that was being looked for. And so you've got to do. But if you look at the people that we're talking to, no one is indexing the internet. Everyone has got different data sources, they've got different inputs, different outputs, they've got different questions coming from multiple user communities. And so if we actually stack up the requirements of what to do and the MapReduce was originally intended to do, and what people are trying to do with it today, we don't actually get an pretty good fit. So from our perspective, Hadoop really wasn't designed for doing BI, which is not Hadoop in any way, because that's not what it was originally designed to do. It's just a statement of fact. So if we look at the strengths, we obviously like the distributed file system, the scale out quality hardware, but it just wasn't designed for business intelligence. Let's take a second to think about NoSQL, the NoSQL databases, and BI. Obviously, the advantage of the NoSQL databases is that you can lot of that SQL baggage behind, and you can start fresh with a new design, come up with a system that is highly optimized to do something new, something that the relational databases are very, very bad at, where you've got undernumbers of attributes. The problem is, from a BI perspective, in order to present data information to the users, we've got to issue some kind of query. And we're doing this from a piece of software, so we need some way to express that query. We need some kind of language that we can use to express that query. And since we're doing this in code, it would help a lot if that language had some kind of structure. So from the BI tool perspective, the single biggest thing you can do to get a whole suite of BI tools working with your data source is implement SQL. Obviously a problem for the NoSQL databases. Now, the good news is we don't need all of SQL. We don't need CRUD, we just need R. We don't need create insert, we don't need update, we don't need delete. We don't care how those happen because we're not doing that through the BI. We're just reading. So we only need read. We also don't need ACID transactions. Forget that. We can leave all that baggage behind. So that's a lot of baggage we've already left behind. We only need read. When it comes to the read, these are requirements for monitoring. This is our tool that has the most stringent SQL requirements. We need select, we need from, we need where, we require. That's the minimum set of things that we do. The other thing that having order by count distinct seems nice to have, those will improve the performance of our tool, but they're not required. So the good news is that if you want to put BI and reporting tools on top of NoSQL databases, if you implement a very small, specific subset of SQL, you can get that to happen quite easily. The alternative is to use an ETL approach, where you can put an ETL tool, extraction as a load tool, on top of your database, and trawl through and basically populate a relational database on your NoSQL database. Go through and do that on a scheduled basis. Obviously, there's issues with latency and additional hardware. So we took the approach of, since Hadoop wasn't designed initially to do BI, why not add the things to it that it's missing until it can do what we need it to do? Well, to do that, we need some kind of Java embeddable data transformation engine. Ultimately, Pentaho has a Java-based embeddable data transformation engine. The open source project is called Pentaho, but Pentaho product is called Pentaho Data Integration. So what we've done, you're familiar with this architecture, familiar with the data nodes, the name nodes, the task trackers, etc. What we've done is to take our ETL tool and enable it to work with HDFS and MapReduce, and also provide the ability to embed the ETL engine, because it's Java, to execute that on the data nodes. It actually runs within the Hadoop data nodes. There's no web service integration, it's not running on a different port. It's embedded as a collection of libraries into the Hadoop data nodes as a MapReduce class. So this gives you the ability to orchestrate Hadoop with the rest of your data architecture. Because our ETL tool can move files, it can use web services, it can use FTP, it can wait for files to appear, and then once your data, you load data into Hadoop, you can transform it within Hadoop, you can extract data out of Hadoop, you take it from there, put it into any kind of analytical application. So it's a full ETL tool that we have added Hadoop capabilities to, and as I said, the ability to run inside of the data nodes. So this is the more formal diagram we have of our big data architecture. Because of our reliance on SQL, at the moment we need Hive in there to be able to put our BI suite on top of Hadoop. We really need Hive. So what we're typically seeing is that someone will take data that's going into Hadoop, they will parse the information, they will enrich it. So let's take web logs. I'm going to take my web log, I'm going to parse it, I'm going to geocode it, so now I've got geography, I'm going to look at the domains. So now I've got an organization, I'm going to look at the user information, parse out all the agent information. And what I'm going to end up with is a web log record that's actually significantly bigger than the original one. So we're not reducing the data down as we're doing if we're indexing the internet. The index is probably smaller than the internet itself. What we're doing typically with an ETL exercise is the data's getting bigger. We're enriching it. And then what we do is we take that enriched web log record and we put that into Hive so that we can query. what we gain by using our software in these layers is that we can build a continuous set of metadata. We know what data is in Hadoop, we know what data is in Hive, we know what data we've extracted out of Hive into our data mart layer, and we know what we've taken out of our data mart layer and put into our analytical applications. So we can build a single universal metadata map of all the data that's available. And so at this point, from the user's perspective, they can see all of this data, they can query all of this data. The only difference is if they need to go down to Hive, the query is going to take longer than if that query hits the data mart. So this is the aspect where you get to performance tune. The more relational databases you put into that database layer, and it could be Postgres, it could be MySQL, we don't care if it's Hypersonic or Teradata, you can do all kinds of choices for the database. But the more storage you put into that relational layer, the higher percentage of your data has got better performance on it. Now obviously, if we can get very low latency and high performance queries going out of Hadoop, then we don't need that data mart layer anymore. So this may just be a hybrid model that only exists for a few years, while the performance and the capabilities of the NoSQL databases in Hive and Hadoop grow to where we don't need that database layer anymore. So we've got our data integration engine integrated into all these layers, and that provides us with this contiguous metadata. So going back to our more pretty picture, there's our data lake. We've got up in our database queue, we've got our data marts, our data warehouse. But these buckets are basically ad hoc queries where I can go and I can even generate an ad hoc data mart. I can go in and say, I'm interested in these attributes. It'll suck that information out of Hive, put it into MySQL. I'm going to come back after lunch. Now I'm going to slice and dice it inside of MySQL for a couple of hours, and then I'm going to throw it away and go get a different set of data. So this is something that we're recommending for people to do, is to provide the capability to generate ad hoc data marts to offset the performance that we can't get out of the data. So if we look at a demo scenario, we're going to get some data from via FTP. We're going to go get a WebLog file. We're going to check to see whether that file exists within HDFS. If it doesn't, we're going to copy it into HDFS. We're then going to parse it and transform it and put it into a tab-separated file that we then load into Hive. Once we've got it into Hive, we're going to extract a summary and aggregate query from Hive and put that into MySQL. So this is what we talk about, this hybrid architecture of Hadoop and data marts. And then we're going to be able to slice and dice that information. And we've also got the ability to go and execute ad hoc queries. So this is my process, this is my environment, this is my ETL tool. So what you can see here, we've got the FTP WebLog step. We're going to delete the file within HDFS. So one thing we did is we created an Apache virtual file system driver for HDFS. So we can do files, rename, delete using the Apache HDFS driver that we created. But in terms of orchestrating, these are all the options that I've got for managing these files. So I can do SNMTP, I can ping, I can wait for files, I can check to see if files are locked, I can use bulk loaders. So these are the kinds of steps that you see in an ETL tool. And I can use any of these in any combination to move the data around and get it ready to go into Hadoop. Then I'm going to pop it into Hadoop. You can see the local, you can see the address within my new cluster that I'm dropping that file into. And then we're going to execute this thing called parse WebLog. There's a transformation. And what we're doing here is we're reading from that WebLog file, and I've got two different methods of doing that. I can read the file via HDFS. This injector step is used for MapReduce. If I want to execute this within the data node as part of a MapReduce job, the MapReduce job will inject rows of data into this injector step. I'm going to parse it out. I've got all kinds of logic in here for enriching the data. I'm working at 1 day a week. I'm working out some metadata about the URL. So based on the URL, I know what part of the website they were on, so I'm adding some metadata about the URLs. I'm parsing out the hidden information, where else is uploaded, etc. You can see the additional fields of data that we're adding into this data stream. Then I do my geocoding, my organization lookup using maximize. And I clean up any temporary fields and I write that out to my file. I'm writing out a tab separated file. This is what we're going to load in the file. So when I go back to my process, the next thing that happens is the Hive load. This is a very simple statement. For those of you that are familiar with Hive, we're basically doing a load Pentaho. So I'm taking the file that is intended to do, and I'm just loading that into my web load table on Hive. Operation. Then my final step here is my queue load. What we're doing here is we're extracting, you can read that SQL statement, but we're pulling out the hit count, day month year, data, the operating system, family, the browser, some geographic information, the names of the country, country region. Aggregate, we're doing a group by, we're going in high, extract the information now that I know I'm going to analyze on a regular basis. I'm going to use every single day, I'm going to come through, analyze this by browser, by operating system, by country, region, etc. And then I'm using MySQL, I'm going to dump this into MySQL table. So that's the entire process. Look at the, just for reference, these are all the options that you have when you're dealing with data. So you can read from flat files, from databases, from Salesforce.com, from SAP. You can, all kinds of transformations that you can do. These are just completely graphical. You drag them in there, change the settings. Lots and lots, I think over 150, 160 different steps you can do. Statistics, mapping, offloading. So I can now execute this. This will go get the file from FTP and load it into HDFS, execute a transformation to parse and enrich that information, and load it into Hive. It'll extract the information out of Hive and put a summary into MySQL. And I can do all of that, just drag and drop. There's no coding involved. It's self-documenting, so there's a step. I can click on a button and it will generate the documentation for exactly what this transformation is doing. One thing people like about this is the learning curve is a lot lower, the documentation and maintenance costs are a lot lower than handcrafting MapReduce costs. And in some cases, this is actually, the data is processed quicker than handwriting in MapReduce jobs. Because we can, this transformation executes as a single map job, so we don't incur the cost of multiple map steps and passing the data between the map steps in the face of taking the raw data coming in, parsing it, working on it, and then turning it back into another single element to pass to the next map task is inefficient. And so we don't have to do that if this transformation takes a single task. So let me go and show you what the output looks like. Go look at the SQL table. We've got 6 minutes left, and I can execute it. It's not going to finish within 6 minutes. So I'll just show you what the output, the end result looks like once it gets into MySQL. So here, this is the information that we extracted out at the very end. And this is what we talk about when we say OLAP, online analytical processing. This is the data that has come out of the end and is now in MySQL. And I can very quickly slice and dice, look at this data. So this is how the ISO is sitting on top of MySQL has been extracted from Hive. We can also issue queries, reporting queries directly down into Hive. Got a different interface for doing that. We select the elements you want, you can filter them on, you can sourcing. From there you can generate Excel files, you can generate PDFs. English remaining on over the FAQ. So we've been contributing to the Apache project, we've been contributing to the Hive JPC driver, and we've contributed to the Apache HDFS driver for HDFS. We don't at this point plan to have our own distribution. We're trying to support the distributions that are out there. We're working with 20.2. We don't, using Pentaho software, we don't, all of the existing maps, reduced jobs will work. Nothing, we haven't changed any of the APIs, everything we've got will work already. We're a BI company. We support many different data sources. Hadoop and Hive just one of those. So we're looking to partners to provide support and services for implementation beyond the Hadoop side. The beta program is over. This is our final slide. The software can be downloaded. I've got some initial slides on data warehousing. I will skip those and go to questions. You can go to yahoo.com/Hadoop. There's also an email address and there's a form out there on our website. Questions?
I have two questions. On the ETL side, I saw you have workloads. When that gets executed,
so the question is, what happens when you actually execute that ETL process? What we have is the Java engine, ETL engine is embedded to the libraries. So we have a map task that executes the ETL engine and passes the rows of data from the reader into the ETL engine. So the ETL job, at this point, the ETL job cannot be composed into a series of MapReduce jobs. It executes as a single map task. But you can, if you want to, there's some things that you want to do on the other side of the map, you can execute it as a map task. So you can have multiple ETL transformations. One runs as a map, one runs as a reduce. But essentially, we've got map and reduce tasks that execute the ETL engine. Okay, this question about metadata. We have a metadata tool, a metadata editor, and that's the logical layer that the user sees. So we have a tool for editing that. So anytime your physical data changes, you can go and change the metadata model. What that means is you can change the physical structure of the files within Hive, the tables within Hive, and modify the metadata to accommodate that change. And all of your existing reports will work. So you can take a table and split it into two. So you now got a new table. When a user goes in to run a report they created yesterday, it will still work. We will now generate a SQL statement that hits the two tables. Yes, the answer is no, I'm editing. Okay, I think in order to keep on track, I need to get out of here and go over to Mr. John. Thanks very much.
Okay. So many.